Alright, in the last screencast, we learned about vector components, how to write it in component form, right? Literally, it's just your x comma y, the x length and the y length of your resultant vector. How do you find the length, the magnitude? You use the Pythagorean theorem, right? How do you actually do vector operations? Right, if it's a scalar, you just multiply everything by a number. You multiply both your x and your y by a number, versus addition and subtraction for vectors. You add the x's together, and you add the y's together. Alright, a unit vector has a length of 1, and so if I give you a vector, all you have to do is find the magnitude, and then divide all your sides by that magnitude, so that way the length is 1, right? So here, our hypotenuse was 1. Alright, the unit vectors are in the same direction. The unit vectors are in the same direction as your x and y. Axes are denoted by I and j. So I hat, j hat, these are standard unit vectors, right? Any vector can be represented as a linear combination of I and j, literally ai plus bj. So notice j is in the y direction, I is in the x direction. J has no x component, and I has no y component. Okay, so let dE be the vector with initial point D at negative 3, 3, and a terminal point E at 2, 6. Write dE as a linear combinations of vectors I and j. So going from D to E, that's our vector. Okay. So just so you know, I might write it as like I hat and j hat because this is in physics. You use these unit vectors, and k hat is in the z direction. I is in the x direction, j is in the y direction, and k hat is in the z direction. I don't think you've dealt with z before, so we'll ignore it. So the first thing we must do is find the component form of dE. Okay, to find component form, remember, you just have to do x2 minus x1. Oops, yes, okay. So to find component form of dE, this is x2 minus x1, comma y2 minus y1. So this is going to be, 2 minus a negative 3, comma 6 minus a negative 3. So that's just going to be 2 plus 3, okay, so 5, comma 9. That is the component form. Okay, next step. We must rewrite it using a linear combination of standard unit vectors. Okay, so all that means is we take A I hat plus B J hat. Take your x, which is, that looks like 97. Okay, take your x, which is 5. So this is 5 I hat plus 9 j hat. So if this was a negative 9, right, 5, negative 9, it would be minus j hat down here, but it's not negative. So that's it. So to actually rewrite it, we would say, maybe, okay. So you can like make it really, really bold. That also is a thing. Make it really, really bold, whatever. I use the hats because that's what I used in college. I and j. So we wanted to write dE as a linear combination, so it's going to be 5 I hat plus 9 j hat. Alright, if the magnitude and the angle of vector v make with the positive, okay, if the magnitude and the angle of a vector v makes with the positive x-axis is known, then it's possible to decompose it into its horizontal and vertical components using trigonometry. This is exactly what we've been talking about, right? How do you find the x component? Oh, cosine of our x is going to be, cosine of our angle is going to be x over the hypotenuse. The hypotenuse length is your absolute value because that's your magnitude. So it's just x, absolute value of v, times cosine. Similarly, y is just absolute value of your hypotenuse times sine. Therefore, we can write it as, right, so this is your x, this is your y. So my x was the hypotenuse times cosine. My y was the hypotenuse times sine. So instead I could say the absolute magnitude of our resultant times cosine I hat plus the absolute magnitude of our resultant vector times sine j hat. Literally, this whole thing is just x I hat plus y j hat. Perfect. That's all it is. Just a review. Alright, example 6. Find the component form of vector v with magnitude 7 and an angle 60 degrees. Okay, we want component form. We got this. So, draw yourself a little picture. Alright, the first thing I'm going to do is, let's see, it has magnitude 7, an angle 60 degrees with the horizontal. So, this portion right here is going to be your x component, and this portion here is going to be your y component. Using SOHCAHTOA, you know that the x component is going to be the absolute value, oh my god, come on, erase. Okay, so the x component is going to be the magnitude of your resultant vector, aka we already know that's 7 times cosine theta. So 7 cosine of 60 degrees is going to be 3.5. And to find my y component, my y is going to be the magnitude of my resultant times sine of theta. So my y is going to be 7 times sine of 60 degrees. So this is just going to be 6.06. So to write this in component form, I would say 3.5, comma, 6.06. That's it. It's not really anything different that we've done, right? We worked with breaking triangles into its components. What we did not do yet was write them in component form, so putting it all together. Alright, example 7, find the direction of the angle vector p, which is 2, 9. Alright, so remember, this is x, this is y, and if you have positive x and positive y, this means we're going to be in quadrant 1. So you can go ahead and draw this triangle out if you want. Blah, blah, blah. Okay, so over 2, up 9. So this is my vector p. Alright, so this guy right here, that's my vector p. Whatever. Direction, angle. We want the angle, right? The direction is going to be the angle. Okay, well, I have a triangle, and what I want is this angle, so we can use SOHCAHTOA. So recall, tangent of theta is going to be y over x. Thank you, chapter 4. So this is 9 over 2. So to actually solve, right, so we have tan of theta is equal to 9 over 2. So if I use tan inverse of 9 over 2, make sure you're in degree mode, is going to be 77.5 degrees. And we're good, right? Because we know it's in quadrant 1, so we know this is 77.5 degrees above the horizontal, and that's it. That's all we need to do. Alright. A soccer player running forward at 7 meters per second kicks a soccer ball with a velocity of 30 meters per second at an angle 10 degrees with the horizontal. What is the resultant speed and direction of the kick? Ooh, this one's a little more hard. This is a little harder. Okay. So, let's draw an arrow. Alright, so they're running forward at 7 meters per second, and they kick the soccer ball at 30 meters per second at an angle of 10 degrees. So I have one vector, right, I should change that color. Let's have it be green. Green. Close. Yes, green. Okay, cool. So this is my first vector. This is going to be 30 meters per second, right, and it's an angle of 10 degrees with the horizontal. My first vector was my soccer player running forward at 7 meters per second, and this is along the ground, so he's at, or she, whichever one, whoever the soccer player is at an angle of 0 degrees. Okay, so we want the resultant speed and direction. So the first thing we're going to do is find our vectors, put our vectors in component form. So I'm going to let V1 be my soccer player. I'll let V2 be the ball being kicked. So we need to break them into components. So keep in mind, V1 is all horizontal because he's only running forward, or she. So my person, I chose soccer player Noah, right? He's another one of my math classes, right? So Noah's playing soccer, he's only running forward. Now I would want to find V2 in component form, and this is going to be of the soccer ball. So this one's a little more challenging, right? So we have to break it up. So here's my, let's see, the magnitude times cosine is going to be my x, and then the magnitude times sine is going to be my y. Awesome. Okay, so plugging in, we see V2 is going to be, okay, this is 30 meters per second, an angle of 10 degrees, so 30 cosine 10 degrees, comma 30 sine 10 degrees. So my second vector is going to be, let's see, if you plug this in, you get 29.5 meters per second, comma 5.2 meters per second. Okay, so we have them broken up into components. The third thing we need to do, because we're trying to find the resultant speed and direction of the kick. So we need to combine, or we're going to add our two vectors together, right? So I just have to add my x's together, add my y's together. So my resultant is going to be 7, 0, plus my second vector, 29.5, 5.2. So this is going to be 36.5, 36.5, ooh, you know what, let me do another color, okay. So this is 7 plus 29.5, so 36.5. Then I'm adding 0 plus 5.2, plus 5.2. And then to, alright, so that's my resultant. Okay. That's my resultant. And lastly, I need to figure out the speed. Okay, so with the resultant speed direction, now I have the x and y components of the resultant. I actually need to find what the magnitude would be, right? The speed is the magnitude of, right, the absolute value. So the magnitude is going to be the square root of 36.5 squared plus 5.2 squared. And that's roughly going to be 36.9 meters per second. Okay, so that is the resultant speed. Not quite done yet. We need the direction of the kick as well. Okay, to figure out the direction of the kick, alright, we're using tangent of theta is just y over x. So my angle is going to be tan inverse of my y, which is 5.2, over my x, which is 36.5. So you get an angle of 8.1 degrees. So the final answer is going to be 36.9 meters per second at 8.1 degrees. Perfect. Hope you have a great day. Come with questions tomorrow.